Hey guys, welcome to question 1 for the 2017 level 2 calculus paper. Okay, we get straight into it. Question 1, a function f is given by f of x is equal to x to the power 5 plus 3x squared minus 7x plus 2. Find the gradient of the graph of the function at the point when x equals to 1. Okay, so for this question, we need to differentiate to find our gradient function first. Okay, so we're going to find what f dash of x is, okay? So f dash of x, okay? And that equals to 5x to the power 4 plus 6x minus 7. So now we simply substitute x equals to 1 to find our gradient. So we'll say f dash of 1 equals to 1 to the power 4 plus 6 minus 7. F dash of 1 equals to 1 to the power of 4 is 1, 5 plus 11 is 4. Should give you f of 1 should be 4. And getting f dash of 1 equals to 4, that'll get you an achieved grade here. Alright. Find the equation of the tangent to the graph of the function f of x equals to 6 plus 14x minus 2x cubed at the point 218 on the graph, okay? So once again, the first thing we gotta do is just differentiate to find our gradient function. So f dash of x equals to 14 minus 6x squared. Okay, so now we're trying to find the equation of a tangent to the graph at the point of 218, okay? So therefore, when x equals to 2, so when x equals to 2, so we know our equation for a tangent is y equals to mx plus c. That's our equation for our tangent, okay? So so basically we're trying to find what is the gradient of the graph when the x equals to 2, okay? So f dash of 2 equals to 14 minus 6 to the power of 2. F dash of 2 equals to 14 minus 2 squared minus 24. F dash of 2 equals to negative 10. So therefore we know that our gradient is negative 10 for our tangent. So therefore we can rewrite our equation as y equals to negative 10x plus c. Okay. Okay, so now we can substitute our point 218, okay, in order to find our c value, okay? So you know that our tangent of the graph passes through 218, so say 18 equals to negative 10 times of 2 plus c. 18 equals to negative 20 plus c. C therefore equals to positive 38, okay? And therefore you rewrite your final equation as y equals to negative 10x plus 38. And this will get you a merit grade here to get to a final answer. To get the achieved grade, you're looking at the correct derivative and gradient found. So therefore you're finding the gradient equals to negative 10. That'll get you an achieved. Okay. The movement of an object is recorded from the time it passes a fixed point after t seconds at a speed of v meters per second, which can be modeled by the function v of t equals to 0.5t squared minus 2t plus 1. Use calculus to find out how long it takes to reach an acceleration of 2.8 meters per second. Okay, so first step here, you know our acronyms. Okay, so we know acceleration integrates to velocity, which integrates to distance. Okay, so now right now we have our v of t, so we have our v of t. So as you can see, we need to differentiate to find our a of t. Okay, so we'll say that just say that a of t equals to t minus 2. Okay, so we can be modelized. So use calculus to find out how long it will take to reach an acceleration of 2.8 meters per second. So substitute our acceleration equals 2.8. So 2.8 equals to t minus 2. Therefore, t equals to 4.8 seconds. And getting t equals to 4.8 seconds will get you a merit grade here. To get an achieved, you have differentiated correctly. So you see a of t equals to t minus 2. That'll get you an achieved. Alright, next question. A tangent of a graph of a function f of x equals to 3x squared minus 4x is a gradient of 2. And it passes through the point 5a, where a is a constant, okay? So find the value of a. So right now we have our equation for a tangent. Our equation for a tangent is y equals to mx plus c, okay? We know that y equals to the gradient of 2, so 2x plus c, okay? And it passes through the point 5a, where a is a constant, okay? So, first thing we gotta do, we gotta differentiate to find our gradient function. So f dash of x equals to 3x squared minus 4x, okay? Sorry, so basically now we have our gradient function. Okay, we know our gradient is 2. So trying to find what is our x value when the gradient is 2. So 2 equals to 3x squared minus 4x. 0 equals to 3x squared minus 4x minus 2. We get our calculator here. Calculator. Where did I put my calculator? Oh dear, sorry, hold up, guys. Alright, so plug it into our calculator here. We'll say that equation, polynomial degrees of a, -2, -4, sorry, and -2. Therefore, our x values are okay, sorry. I realized what I did wrong. I didn't even differentiate my thing. Sorry, so f of dash of x is 6x minus 4. So therefore we substitute 2, and therefore we say that 6x equals to 6x equals to 1. So now we substitute 1 back into our original equation to find our y value when x equals to 1. So therefore we say f of 1 equals to 3, 1 squared minus 4. F of 1 equals to 3 minus 4. F of 1 equals to -1. So therefore we can find our a value and pass it through the point of so we found f of 1 equals to -1. Okay, so now we have our gradient. Okay, so we know our gradient is 2, and we know that y equals to 2x plus c. Okay. Okay, so basically we know that -1 equals to 2x 2x, where x equals to 1 equals to 2 plus c. Okay, our c value is c equals to -3. Okay, so y equals to 2x minus 3, and therefore if we substitute x equals to 5, now we should be able to find what our a value is. So y equals to 5 times 2 minus 3. Therefore y equals to 7. Therefore it passes through the point 5 of 7. Okay. Getting all the way to 5 to a equals to 7, you'll get the excellence grade. To get a merit grade, you find the correct y coordinate of the original function. So f of 1 equals to -1. That gets you a merit. To get achieved grade, so derivative equals to 2, and x coordinate calculated, so x equals to 1 here will get you an achieved. Sorry guys, the last video got cut off, so we're going to continue back onto part E. The function f of x equals to x cubed plus ax squared plus bx plus 2 has turning points when x equals to -1 and x equals 3. Find the values of a and b. So first we find the gradient function, so f dash of x equals to 3x squared plus 2ax plus b. Okay, so we know when x equals to -1, the gradient equals to 0, so f of x equals to 0. And when x equals to 3, f of x equals to 0. And that's because there's a turning point, and the gradient at a turning point is 0. Okay, so we say that 0 equals to 3, -1 squared plus minus 2a plus b. Okay, and 0 equals to 3 squared plus 6a plus b. Because they're both equal to 0, we can say that they're equal to each other. So we'll say that 3 minus 2a plus b equals to 27 plus 6a plus b. The two b's cancel out, and if you move these to the other side, okay, so say 24 plus 8a equals to 0. Therefore, a equals to -3. Okay, so we bring back so we'll say that 3 minus 2a plus b equals to 0. And because we find a equals to -3, we can therefore say that 3 plus 6 plus b equals to 0. So therefore b equals to -9. Okay, so to find your a and b values here, that'll get you an excellence grade. Okay, to get your merit grade, you're looking at substituting the x equals to -1 and x equals to 3 into the gradient function. So that's this part here will get you a merit grade. To get excellence grade, you're looking at derivative found and equated to 0. Okay, so that would just be no, sorry, this part will be an achieved, this part. This will be the achieved, and this will be the merit grade, okay. Alright. The diagram below shows the graph of the function y equals to f of x. Sketch the graph of the gradient function y equals to f dash of x on the axis below. Both axes have the same set of scales. Alright, so simply we're going to find the equation of the parabola. So that's ay equals to a x plus 3 x minus 2. Okay, we're going to substitute a point. We're going to substitute on 1, 2, 3, 4, 5. We're going to substitute this point. So 1, 2, 6 equals to a negative 1 plus 3 negative 1 minus 2. 6 equals to a 2 negative 3. A equals to therefore equals to negative 1. Y equals to negative of x plus 3 x minus 2. If we open this up, we'll say that y equals to negative x squared plus x minus 6. Y equals to negative x squared plus minus x plus b plus 6. So therefore y dy over dx equals to negative 2x minus 1. Okay, now we're going to plot this linear graph onto our set of axes below. Okay, so negative 2x minus 1 is our equation. Okay, so when x equals to 0, y equals to negative 1. Yeah. So this point will be here. When x equals to negative 1, then when x equals to negative 1, y equals to 1. So this will be here. When x equals to negative 2, then y equals to 3, and so on. So up. So this will be here. This will be here, and therefore this will be down here. And then we'll just join it up with a line, okay, and we'll call that our linear equation, okay. Yeah, it's not 100% accurate, but there we go. So that's our linear equation right here, and getting the correct equation, linear equation here will get you an achieved grade. Alright, the graph of the function f of x equals to 2x squared plus bx squared minus 2 has a turning point when x equals to negative 1. Find the value of b. So once again, the first thing we do, we differentiate our function. Okay, we'll say f dash of x equals to 6x squared plus 2bx. Okay, so we know that when x equals to negative 1, our gradient equals to 0. So we'll say 6 squared plus negative 2b equals to 0. So 6 plus negative 2b equals to 0. Therefore, our b value should give us to be 3. Okay, so therefore we'll say that our we just find a value of b here. That will get you a merit grade here. Okay, so to get an achieved, you find the derivative and equate it to 0. So therefore, this will get you an achieved. Alright, use calculus to show that the line of y equals to 15x minus 12 is a tangent to the graph of the function f of x equals to 4x squared minus x plus 4. So once again, the first thing we're going to do is we're going to differentiate the function. We're going to say f dash of x equals to 8x minus 1. Okay, as you can see, it's we have a gradient here. Our gradient is said to be 15, so we're going to find what is the x value when the gradient is 15. Okay, so 15 equals to 8x minus 1, and therefore x equals to 2. Hey guys, welcome back. The video got cut off once again, and I apologize for that. Pretty annoying, but sorry about that. So we've just found out that x equals to 2. Okay, so now we're going to prove that the line of y equals to 15x minus 12 is the tangent to the graph. And that we can only do that if we substitute 2 into the equation. If we substitute 2 into the equation of the linear graph, it should equal to if we substitute 2 into the function. Okay, so we're going to say that y equals to 15 times 2 minus 12. That should give us y equals to 18. And if you substitute 2 into the function, that should also give us 18, okay? So we're going to say f of 2 equals to 4 minus 2 plus 4. And therefore f of 2 also gives us 18. And because these two give us the same answer, therefore it is the tangent of a graph. So getting all the way up to here will get you the merit grade, okay? To get an achieved grade, you're looking at substituting 15. So about here, that'll get you an achieved. Alright. Use calculus to find the value of k if the line y equals to 6x plus k is the tangent of a graph of the function f of x equals to x squared plus 2x minus 1. So once again, we're going to apply the same rule as the above question, but instead of knowing but this time we don't know what our k value is, okay? So first thing we got to do is we're going to find f dash of x equals to 2x plus 2. We know our gradient is 6, so we substitute 6 equals to 2x plus 2 to find where, when is the gradient 6, okay? Therefore, we have our x equals to 2 again. So therefore, if we substitute x equals to 2 into the function, it should equal to when x is substitute 2 into our tangent, okay? So we can say f of 2 equals to 2 squared plus 2 minus 1. That gives us f of 2 equals to 7. So therefore, 7 should also equal to this if we substitute x equals to 2. So we're going to say 7 equals to 6 of 2 plus k. 7 equals to 12 plus k. K equals to negative 5. Okay, so therefore we can rewrite our equation as y equals to 6x minus 5. Okay, so getting all the way to 6x minus 5 here will get you an excellence grade. To get a merit grade, you're finding the coordinates of the x and y values. So you're finding x equals to 7. You're finding y equals to 7 and x equals to 2. That'll get you a merit grade. And to get an achieved grade, you're finding you're substituting 6, making the derivative equal to 6. That'll get you an achieved. Alright, moving on. Use calculus to prove that the graph of the function y equals to x cubed bracket 3 minus x bracket has a local maximum when x equals to 9 divided by 4. Justify that the turning point is a local maximum. Okay, so basically first we need to expand. Okay, so we go y equals to x cubed times 3x cubed minus x to the power 4. So therefore we can say that our f dash of x equals to 9x squared minus 4x cubed. We make our gradient equals to 0, okay, to find our turning point, because at the turning point our gradient is 0. So 0 equals to 9x squared minus 4x cubed. Okay, so therefore we're going to take the x squared out. So we're going to say 0 is equal to x squared 9 minus 4x. Therefore, x equals to 0 or x equals to 9 over 4. So now we're going to find f double dash of x, okay? We'll find f double dash of x and see whether 9 over 4 is positive or gives a positive or a negative result, okay? So f double dash of x equals to 18x minus 12x squared. Okay, we're going to substitute 9 over 4. So f double dash of 9 over 4 equals to 18 times of 9 over 4 minus 12 times 9 over 4 squared. And that should give you your answer as negative 20.25. Because this is negative, okay, therefore we can say therefore we can say it's a positive maximum turning point. Okay, so getting all the way to the justification, so that's saying that the double dash of x is negative, so therefore it's a maximum turning point, and getting your x equals to 9 over 4, that'll get you an excellence grade. To get a merit grade, you're looking at cubic equation solved, so you're getting x equals to 0 or x equals to 9 over 4, that'll get you a merit. To get an achieved, looking at derivative found, so therefore finding f dash of x, that'll get you an achieved. Alright, moving on. Gradient graph of a function f of x is given by f dash of x equals to 6x squared minus 2x plus 4. The point 1, 3 lies on the graph. Find the equation of the function f of x. So we know we have our gradient function, so we need to integrate to find our function. Okay, so this time we're reversing our steps. Okay, we'll say f of x equals to, you increase the power by 1, and then you divide the coefficient by the power. So that say that 6x cubed divided by 3 minus 2x squared divided by 2 plus 4x, and don't forget the plus c at the end. So f of x equals to 2x cubed minus x squared plus 4x plus c. We know the point 1, 3 lies on the graph, so we're going to substitute y equals to 3 and x equals to 1. 3 equals to 2x, 2x to power, sorry, not 2x, 2, 1 to power 3 minus 1 plus 4 plus c. 3 equals to 2 minus 1 plus 4 plus c. 3 equals to 1, 5 plus c. c therefore equals to negative 2. Okay, so therefore your equation will be f of x equals to 2x squared minus x squared plus 4x minus 2. And getting all the way up to here, you'll get your achieved grade here. Alright, moving on. Okay, an object can move in either direction on a straight track and has a constant acceleration of negative 4 centimeters per second. A fixed point P is marked on the track. When a recording of the object motions begin, the object is 12 centimeters away from P, is moving away from P, and has a velocity of 6 centimeters per second. Use calculus to find the speed of the object 5 seconds after its motion began being recorded, okay? So it has a constant acceleration of negative 4 centimeters per second. So it's going to say our acceleration equals to negative 4. Okay? So that's our acceleration, okay? It has a constant acceleration of negative 4 centimeters per second. Okay, so our acceleration is equal to negative 4, okay? So therefore, okay, we're going to say that, okay, so therefore we're going to say that our velocities, we're going to integrate to find velocity. So v of t equals 2, we're going to integrate, so negative 4t plus c. So we know when the time equals 0, it had an initial velocity of 6 centimeters per second. So therefore, when the time equals to 0, the velocity equals to 6. So 6 equals to negative 4, 0 plus c. c therefore equals to 6. So therefore, you have your v of t equals to negative 4t plus 6. So find the speed of the object 5 seconds after the motion began being recorded. So we're going to substitute t equals to 5. So v5 equals to negative 20 plus 6. Therefore, our v of 5 equals to negative 14 centimeters per second. Okay. Getting the correct speed here, okay. Getting the correct speed here will get you an achieved grade. Alright. What is the maximum distance of the object from point P? Justify this is the maximum distance, okay? So therefore, we have our v of t, so we're going to integrate again to find out d of t, so s of t. S of t equals to, increase the power by 1, so divide by 2 plus 6t plus c. S of t equals to negative 2t squared plus 6t plus c. You know that when recording the object motion, the object was 12 centimeters away from P. So when we started recording the time, so when time equals to 0, the distance equals to 12. So we're going to say when t equals to 0, s equals to 12. Therefore, our c must be equal to 12. So our s of t equals to negative 2t squared plus 6t plus 12. What is the maximum distance of the object from the point P? So, okay, so right now, okay, we're looking at the maximum distance of the object from the point P, okay? So we have our s of t right now, okay, and to find our maximum distance, okay, our maximum distance can be found, okay, so we need to differentiate back into our v of t. So I'm going to say, we can just say s dash of t equals to negative 4t plus 6. So we're back to our original equation. So we're going to find what is the t, okay, so basically what we want to do here is we want to find out, sorry. So, okay, we want to find out, when how far, so how long has it been after I click the stopwatch, we have reached the maximum distance, okay? And we do this by substituting the turning point. The turning point, the gradient equals to 0, so substitute the gradient equals to 0. negative 4t plus 6. Negative 6 equals to negative 4t. Negative 6 divided by negative 4 equals to t. Okay, so that's our s of t. So that should give us t equals to what is that? I cannot simplify an easy equation anymore. So that should give us can't even do this. Negative 6 divided by negative 2. No, not negative 6 divided. Negative 6 divided by negative 4. 1.5, thank you. T equals to 1.5 seconds. We go back to our s of t. So our s of t was negative 2t squared plus 6t plus 12. Substitute t equals to 1.5. Plug that into our calculator. Should get our distance should be equal to 16.5 meters. So now we need to justify that it's a maximum turning point, okay? So we have our s dash of t. So we're going to find our s double dash of t, okay? S double dash of t gives us negative 4. That is negative, so therefore this is a maximum distance. Okay? So therefore, getting all the way up to finding the correct distance and justifying that it's the maximum distance will get you an excellence grade. To get a merit grade, you're finding the correct value of s. So you find that s equals to 16.5 meters, you get a merit grade. To get an achieve, you're finding the equation for s, so s of t. So basically getting this equation correct, you get an achieved. Alright. Okay, welcome back. Sorry, the video got cut off again. Okay, that's the third time. Okay, sorry guys, I found a way to get my screen recorder fixed. Okay, so it won't happen again in the future video. So sorry about that. So find the maximum volume of an open box, i.e. a box with a base and sides but no lid, that can be made from a rectangular piece of cardboard measuring 20 by 30 centimeters by removing the corner squares and folding around the dotted lines. Justify if it's the maximum volume. Okay, so so we have our 20 by 30, okay, and we'll define our remove side as x. Because it's a square, this is also x, okay? So therefore, our volume equals to base times height times width. We're going to say our height equals to x, our base equals to 30 minus 2x, and our width equals to 20 minus 2x. See, this is removing the sides. So volume equals to x times of 30 minus 2x times of 20 minus 2x. Therefore, V equals to x of 600 minus 60x minus 40x plus 4x squared. Therefore, V equals to 600x minus 120x minus 40x squared plus 4x cubed. So therefore, now we have our equation. So now we're going to find our gradient function. So we should simplify first. Probably we should probably simplify first. So it's 480x minus 40x squared. So now we can do our v dash of x equals to 480 minus 80x plus 12x squared. Okay, and now we're going to substitute it equal to 0. Okay, so we're going to plug this number into our calculator. So we're going to say our a equals to 12, b equals to negative 80, and 400. Plus positive 12x squared, 80x. Oh yeah, sorry. I see what I did wrong. Sorry, I made another mistake. Sorry. Making some algebra mistakes here. Some simple algebra. Okay, so if we expand this, it should get 600x minus 60x squared minus 40x squared plus 4x squared. Okay, so v equals to 600x minus 100 minus 100 x squared plus 4x cubed. Sorry, this is still cubed. Okay, so v dash of x equals to 600 minus 200x plus 12x squared. Now it should work, so sorry about that, guys. So we get our x equals to 12.74 or x equals to 3.92. Okay, so now we're going to try to find which one is the maximum. Okay, so therefore we're going to find v double dash of x, and that should give us negative 200 plus 24x. And we're going to see which one gives us a negative answer, okay? So we're going to try, we'll try 12.74 first, okay? So v equals to negative 200 plus 24 times of 12.74. This, as you can see, this is probably going to give us a positive result. So 24 times 12.74. Yeah, that gives us positive 54.8. Okay, so therefore this is positive, therefore this is a minimum turning point. Okay, if we say v double dash of 3.92 equals to negative 200 plus 24, 3.92. And that gives us negative 105.92. This here is negative, so therefore this is the maximum turning point. Okay, so getting the correct, finding the correct points, so that's x equals to 12.74 and x equals to 3.92, and the correct justification will get you an excellence grade. To get a merit grade, okay, so finding the x values here, that will get you a merit grade. To get an achieved grade, you're looking at relationship form and differentiated. So, here, this here will get you an achieved. Alright, so thank you for watching this calculus walkthrough, okay? I'm sorry if the video got cut off multiple times, okay, I apologize for that. It won't happen in the next video, but nonetheless, I hope you enjoyed the video, and I hope to see you all in the next one. Thank you, bye.